Hi everyone, welcome back. So this is another data analysis video, and this is the last video I'm going to do about tidying and wrangling your data for now. I've called it More Data Wrangling 10. I've saved this one for the last, but it's quite an important and useful one. I'm going to kind of show you how to convert a data frame that's been created in the short and wide format to long and thin format. So to start, I'm going to import pandas and numpy as normal. Importing pandas as PD, numpy as NP. I've explained that multiple times now. And I'm going to import a data set that's obviously saved on my laptop. It's called hrpolygraph.csv. I'm going to import it and give it the name DF, the nickname DF for data frame, using the PD pandas.read_csv method. So if I run the second cell, what you can see here is a data frame. And what this relates to is a study where participants took part in like a lie detector study. Basically, each row represents a participant. So ID as an ID number for each participant. Yeah, and there are 80 participants in total. And there are three columns that we're interested in here: lie, truth, and coloured squares. And basically the scores, the values 58.53, 84.85, 53.78, the scores under each of these represent mean arousal, so physiological arousal. And the labels for the columns, the headers for the columns, represent their arousal under different conditions, different treatments of the independent variables. So the first column here, when a participant lied, when they told the truth, and coloured squares here is like a control condition essentially. They looked at coloured bits of paper just to get a baseline reading of their arousal. Okay, so here for this top row here for participant 1, we've got their arousal when they lied, their arousal when they told the truth, their arousal when they did a control condition. It's actually a mixed design data set, because we then add this additional variable of framing here, and I won't say too much about that because it's not hugely relevant for what I'm going to do in this video. But what we've got here is what's known as a short and wide data frame. So we've got essentially a measure for the same participants spread across 3 columns. So arousal is spread across 3 columns, and it's broken up by the conditions of a different variable essentially. So I'm not a great fan of short and wide data sets. This was put together by one of my colleagues. And often it's useful to have this in what's known as long and thin format. One of the things I don't like about short wide data sets is the column labels for each of these don't tell you what the variable is, essentially, what the measurement relates to. So what would be useful is to convert this to what's known as a long and thin data set, where essentially it would give us one variable which has each of these 3 levels of the same of condition. Let's say we'll call that condition. So lied, told the truth, did the control condition. So we could create a categorical variable with 3 categories, 3 levels, and then we can have a second variable which we just call arousal or mean arousal, and that would contain the actual arousal scores. So it would essentially be 3 times 80 long. Okay, right. So the way to do that, and one thing I would say in relation to this is that a lot of programming languages prefer, or it's easier to work with long and thin data sets rather than these wide and short versions like this. You can work with them, but you need to know some extra tricks. So I prefer to put, one of the manipulations, one of the things I do to tidy data when I get a data set like this is I try to put it in long and thin format to make it easier to work with in Python, and other programming languages like R seem to work. They seem to be much more efficient. They work better with long and thin data frames. Okay, so first what I'm going to do is create a separate object for the groups, for the 3 variables that we're interested in, or the 3 groups
for our condition lie, truth, and colored square here. And that's all I'm doing here is I'm creating an object called groups, and it consists of those 3 columns from the DF data frame. And if you call groups, press that, you can see it's just extracted those three columns and their scores from the main data frame object. So we've got rid of some other bits of information. So currently the data is short and wide with these 3 categories saved as it's almost like they're saved as 3 separate variables, but we want to convert this to long and thin. And in order to do that, we're going to use the pandas melt method. Okay, so there are a couple of things I'm going to do first. I'm going to create this new object called categorical condition. So we're going to call the lie, truth, and colored squares condition. We're going to give it a name, condition, in relation to that variable. And I'm going to save it as an object called categorical condition. So it's clear. So it makes sense to me that these are 3 levels of a categorical variable. And in order to create that object, I'm using this list method, this list function, and I'm passing groups.columns into it. Okay, groups, what does that relate to? It relates to the groups that we created here. And dot columns is just telling it to use the columns, the column names from that object. Okay. Right, so we're creating a new object called categorical condition. And then I'm going to create this new data frame called groups long. So to represent it's a long and thin version of the data frame. And I'm going to use the pandas melt method. So pd.melt, and then in the parentheses, I'm going to pass a number of different arguments or parameters. So the first is I'm going to say, take the groups object, and the values for the variables are going to be the values from this categorical condition. And the value name is going to be mean arousal. And we're going to ignore the index. We're going to set that to false. So we will retain the original indices. Okay, so if I run this, we obviously don't see any output. But if I call this new groups long object below, what you can see now is it's created, the data frame is now 240 rows long, and it's 0 to 80 stacked on top of each other 3 times. So the first 80 rows are our mean arousal scores for the lie condition. The next 80 will be the mean arousal scores for the truth condition. The next 80 will be our mean arousal scores for the colored squares control condition. And it's just given this the name variable. We could have specified that. We'd have asked for this to be. We could change this and say we want to call this condition, so it's clear. But so that's quite useful, and the pandas index is there, and it seems to be correct. But what would be useful is to kind of attach. We had an original kind of ID, participant ID there, which when we created this new groups object, we dropped. So it would be useful to sort of attach a participant ID back on that maps onto. So we know we've got participant 1 to 80, 1 to 80 again, 1 to 80 again for all 3 levels of this variable. This particular variable, the grouping variable. And the way we can do that is we can just attach, we can create this new, take the groups long object, create this new variable called participant, and all we're going to use for that is the ID number taken from the original data frame. Okay, so we're using the ID variable, this original one that appeared here, and our data frame. And if we run that particular cell, we won't see anything, but if we then call the data frame again, you can see we've now got participant ID, and that should basically run from 1 to 80, and then 1 to 80 again, and then 1 to 80 again. So we now got what was originally this wide and short data frame where we had kind of scores from
what effectively were the categories of one variable spread over 3 columns. It wasn't clear what these were measuring, what they related to. We've now got them in long and thin format, which would be much easier to work to. We can see we've got this categorical variable, and we've got a mean arousal score for each category.